And there we go. Okay, everyone, welcome to tonight's session as we explore Mount Isa, the first 100 years and what we have coming up into the future. I'd like to start tonight by acknowledging the traditional custodians of the lands on which we all meet tonight, and particularly the Kalkadoon peoples whose traditional lands Mount Isa is built on today. We recognise their continued connections to land, waters and culture, and pay our respects to elders past, present and emerging. I'm sure you've all had a read already of the topic for tonight and a bit of the brief blurb. Without further ado though, we might roll into some introductions, a quick run through of events or upcoming RGSQ events and get started. As I said a bit earlier, please make sure to put your microphones on mute and have your cameras off. We are recording this session and hope to release it very soon. In terms of upcoming events with RGSQ, we do have a few more in the next couple of weeks. Full program is available up on our website and events are also appearing on our social media channels. These include our Geography and Conversation, in-person panel style discussion on 29th of August, exploring the Southeast Queensland Regional Plan, which has just been released, public consultation currently occurring. And then rolling into the start of next month, we have our Young Geographers Forum. We've got some fantastic young researchers lined up to present their work and talk about their topics of interest for people just starting in their careers in geography. And then on 12th of September, we have our next Geography Matters, where we're looking at rivers in the sky, atmospheric rivers. With that though, we'll kick off for tonight's event, exploring Mount Isa. Joining us and will be presenting first up is Dr. Richard Lilly. He is member of the Australasian Institute of Mining and Metallurgy, member of the Australian Institute of Geoscientists, and the program leader and co-founder of the National Exploration Undercover School, or NExUS, which aims to prepare Australia's most promising geoscientists for a career in the minerals industry. Between 2007 and 2015, Richard worked for MAUSIMM Mines Exploration, and since 2015 as an industry-funded economic geology researcher and lecturer at the University of Adelaide. In 2022, Richard was named the STEMM Educator of the Year at the South Australian Science Excellence and Innovation Awards for his work with NExUS. Richard is passionate about rocks, ore systems, exploration, and teaching and mentoring the next generation of geoscientists. Tonight, Richard will be interviewed by Damian Kelly. Damian is an internationally experienced petroleum geophysicist with experience in New Zealand, India, Egypt, Argentina, Ghana, and Ireland. Damian's key focus is onshore and offshore 2D and 3D seismic data interpretation, structural model building, and reservoir characterisation, as well as managing those key in and out sourced geotechnical projects. With that, I'll throw to Richard to run through his presentation.
Cool. Thank you very much for that introduction. Very pleased to be here today and presenting to you from my home in Wollonga in lovely South Australia. Can somebody just let me know that that is working, that you can see my screen?
All coming up good.
Excellent. Let me just remove the meeting control bar. There we go. Well, look, thanks very much for having me. It's always a pleasure to talk about Mount Isa. My wife and I and our 3 lovely children, well, 2 of my kids were born in Mount Isa. We lived there for 8 years between about 2007 and 2015. And as we can see, you know, that's eight of 100 years. So we were there for nearly 10% of the life of this town. So it's a remarkable achievement for Mount Isa to exist and what it proves as a town and what it provides as commodities. Obviously, I'd like to acknowledge lots of other people who've worked at Mount Isa. It's a real training ground for a lot of geologists and engineers who go on and do great things for our industry. And obviously, Mount Isa is a great place to live as well. Let me just do this. So it's a big topic to cover in 20 minutes. I actually have a 1-day workshop just on the geology of the Mount Isa deposit, but don't worry, we're not going to go into that. But it is fascinating geology, really very interesting. Paleozoic, so very old, about 1.5 billion years old, the rocks around Mount Isa. There's globally significant copper, lead, zinc and silver mineralization there. It's a case study for mining in far northwest of Queensland. It's pretty hot up there. There wouldn't be too many people living in that part of the world if it wasn't for this large deposit of copper, lead and zinc. Obviously, you've got the social evolution of a city over 100 years. And from a geology point of view, we have a history of changing academic opinion on how this amazing deposit formed. And then, of course, we bring right up to the present day of modern mining and economics and how that affects on the global markets that people sell to. If you're interested in this area, I would highly recommend Geoffrey Blaney's excellent Minds and the Spinifex book. Hopefully, you'll be able to get hold of a copy that's a little better condition than that, but that's a very good read. Covers everything from sort of the evolution of Cloncurry, which, of course, was founded nearly 60 years before Mount Isa. So this is really an introduction to the geology / social history of Mount Isa. And of course, I haven't done this all myself. There's been many, many geoscientists who've worked on the Mount Isa and Cloncurry areas. All the areas are my own, but I also need to put in a disclaimer. I don't work for Mount Isa Mines or Glencore. This is very much, these are views of my own. And please, I'm not representing the company in any form for this talk. So where are we? Hopefully the Queensland Geographical Society should know where Mount Isa is. It's about 950k, which incidentally, having grown up in the UK, that's about Land's End to John O'Groats. So we always used to find it interesting. We had to drive for a day and a half just to get to the beach. And when you got to the beach, you couldn't swim because there's too many jellyfish and crocodiles. But anyway, why are we in Mount Isa? Well, it's part of the Northwest Minerals Province. Now, hopefully you can see my cursor here, but Mount Isa sits here with George Fisher, which is another famously large lead zinc mine as well, just 20k up the road. But you've also, geologically, we're related to, even as far away as the MacArthur River and Century, two very significant lead zinc mines. And of course, in Cloncurry, there's world-class copper and gold as well. So it's a remarkable district. And we call, generally split it in the western succession. So in the Mount Isa district, we have these sediment-hosted deposits. And in the east, we have systems called iron oxide, copper, gold, or IOCG. So sort of lead zinc in the west and copper and gold in the east. And I've just circled some of the large lead zinc mines there, generating a huge amount of income for the state and for the country. Why do we care? Well, it's actually, obviously mining's not everyone's cup of tea. It's very rare to see a positive story about mining in the news, but we can't get away from the fact that we like having solar panels, we like having cars, we like having phones, and we like living in houses and flying in airplanes, and all of that needs materials. And every year we use more and more materials. We're going through a sort of, obviously now into the sustainable energy transition, we're going to need even more. We're going to need to mine twice as much copper in the next 50 years as we've ever mined in the history of humans, so they predict. So we need more copper, we need more zinc, we need more lead. Regular cars have about 20 kilos of copper in them. A Tesla has about 80 to 100 kilos of copper. An electric bus has got nearly 400 kilos of copper in it. So just to meet demand for these new vehicles, we're going to need to mine an awful lot of copper and steel and all the other things. I'm not particularly pro mining. I'm pro rocks. I like rocks. I moved to Australia because I could get paid to look at rocks, which is brilliant. And it would be great, I think, if we used less material. But at the end of the day, people want new things. And if everybody wants to have a Tesla, we need to mine the materials. When I give lectures in economic geology to students, every single chart I show them goes up, whether it's global lithium production, wind power, anything, number of smartphones, number of people connected to the internet, all of these things are going up very rapidly. So unless we come up with ways to somehow substitute these metals, we need to mine. And even at the moment, it's in the news, even this week, there's actually a copper shortage. We're in deficit. This is copper demand modeled from sort of the 90s through to the future. And we're just sitting at this precipice here. We're literally just at the point where this is the copper that we can produce, and this is the copper that we need. And that's going to mean that copper is going to go up in price. All of the metals will eventually go up in price, particularly things like lithium for batteries. A lot of these commodities are just going up and up. And where does it come from? Well, you send people like me out to look for pretty minerals. Hopefully we find some pretty minerals. Those are copper minerals. Then you drill a hole. And if you've got enough of the particular ore that you're after and it's in a suitable form, then you can dig it up. And that's really what mining does. And it provides most of our daily needs these days. Of course, it's divisive. And there's been some shocking case studies of where mining can do better, but I'd still say that Australia is a better mining jurisdiction than some other countries. We have lots more environmental protections. Anyway, and it's also good for the good for the bank balance. Australia is a mega source country, so we're going to be, this is a list of all the minerals that we're predicting, that people are predicting we're going to need, and Australia has by far and away the most known deposits and resources. And of course there's the figure there that Australian mining exports are in the hundreds of billions, and I believe it was over 300 billion a couple of years ago and over 400 billion last year. So it's a lot of money driving the economy, and builds a lot of roads and hospitals, and keeps nearly 250,000 people employed directly as well. Anyway, back to Mount Isa. Sorry, a little bit of a sidetrack there in terms of why we need metal. And we've looked at why we've got lead zinc in one side and copper in another side. Mount Isa, the geology, as I mentioned, the rocks are the host rocks, as we call them, that the mineralization sits in, are around sort of around 1600 million years old, so 1.6 billion years. There was some tectonics, so mountain building, couple of times it opened up and filled with sediment, came together, opened up, filled with sediment, and then the third time it came together, the big squish was around the time that the rocks kind of got into the state they are currently. The Urquhart Shale is the main host unit for the lead, zinc and copper in Mount Isa, and that's dated at around 1650. It was a shallow lake sequence, so there's some that you can even see sometimes. Obviously you can see some ripple marks, and you can also see desiccation cracks, so we know that it did dry out from time to time. Zooming into that little box there, and as I mentioned earlier, the geology from Mount Isa is somewhat linked to up in the Northern Territory as well. All of the rocks are pretty much north-south, as you can see behind me. I'm looking west there. It's quite convenient that the row of hills in Mount Isa is north-south. It helps you orientate yourself on the way back from the pub. And if we take a cross-section through there, you can see that the different rocks are all folded in certain ways, and the Mount Isa ore bodies sort of sit almost on a step. It's like if you've folded something and it sort of folds like that, and the deposit sort of sits on that fault. It's called the Peru fault. And if we take a cross section, you can see this is what we'd call the basement. So that's volcanic rocks, or rocks that are even older than the Urquhart Shale. And the Urquhart Shale dips in like this, and we have the copper ore system, and we'll look into more detail in a moment. The copper ore system sitting essentially on the contact with that basement, and then the lead zinc tends to sit roughly parallel to the layers of rock in the Urquhart Shale, and that's one of the ways that we've ended up having so much discussion as to how it forms. So taking a view of Mount Isa, that's the lead stack, the copper stack, and the sulfuric acid stack. And if you've got sharp eyes, you can even see there's some bright yellow sulfur there. The sulfur comes from the copper refinery. Lead smelted at Mount Isa. Zinc is actually sent away as a sort of concentrate. They don't smelt the zinc there. That's actually sent all the way to the UK for processing. But the copper is processed first at Mount Isa, then put on the train to Townsville. And I put the town, I always found it remarkable that the town pool was literally a couple of 100 meters from the copper smelter, but conveniently the wind almost always blows to the northwest, so fumes tends to go that way. The sort of the elephant in the room is it's the tailings dam back there. Now Mount Isa has actually got quite a lot of cobalt in its pyrite. And cobalt is becoming more and more important as a mineral, and for 100 years they've been throwing away all the pyrite into that tailings dam. So I would not be at all surprised if in the future some very clever person works out how they can extract that cobalt, because it's probably the world's largest cobalt deposit just sitting there at the moment unused. If we take a cross section, so take a knife and slice down along the railway line, that's roughly what Mount Isa ore deposit looks like. We have the lead smelter here, the copper smelter, and generally speaking, the lead zinc ore is closer to the current surface and the copper is a bit deeper, and we'll look at another view of that in a moment. And the original Black Star and Black Rock open cut pits that were there, leading to lead zinc mining, and of course the copper ore bodies go down to beyond, well below 1,500 meters. It's not a competition, but Mount Isa does like to claim that it has the most underground development in the world, over 1,000 kilometers of underground tunnels, and quite impressive. They actually have multiple shafts to get in. People mining this ore body will go down the X41 shaft here rather than traveling underground. It's like a whole city under there. There's crib rooms, there's mechanics workshops. It's amazing. So if we take a cross section through number 1 there, you can see that the 1100 ore body, as we call it, very large, one of the world's greatest copper ore bodies, that sits on the Peru fault with less lead zinc in that part of the system. And if we take a cross section through the northern part of the mine, you'll see there's more lead zinc sort of roughly following the Urquhart Shale, and that the copper is again down near the basement. It's these deeper ore bodies down here that they can keep chasing and are still providing good copper. Here's another cross section. Again, we have the faulted contact, where we have the copper sort of sitting on the contact or closer to, and the lead zinc as you go far away. Interestingly, a lot of the study for Mount Isa was done either at the top or in the copper ore systems. Not many people ever studied sort of where the two sort of lead zinc system and the copper system join. And actually, you know, I'll give the game away here. They don't really join. One doesn't overprint the other. It's actually just one system. So as looking at the rocks, if we're at point A, the rocks look like this. This is chalcopyrite, and we'll have a closer look in a moment. And as you go away from the fault, you get more into lead and zinc, and it's this brown material, that's sphalerite, and that's the main zinc ore. So it's a zoned system, we can call it. Irregardless of how it formed, we know that it's zoned. If you want copper, you need to go a bit deeper. So there's a lovely bit of rock. This is the white mineral, is called dolomite or calcite, with some grey quartz veining over the top of it. And this beautiful yellow gold mineral is chalcopyrite. So chalcopyrite is a copper sulfide. Pyrrhotite is this mineral here, the sort of browny mineral, and that's an iron sulfide. I won't go into too much detail about that. Some of the rocks in Mount Isa look very folded, and I think this is one of the issues. People thought that these rocks might have been folded on the sea floor. This, to me, this is slumping. So, you know, in lake sediments, they kind of slump down and form the kind of crazy ripples like that, and that's slumping. So that's preserving the original texture of the rock. And in between, we have the silver galena and the brown sphalerite, and a little bit of chalcopyrite here as well. And there's some classic photos from underground where you see these sort of very complex folds, again, all slumping of sort of wet sediment that wasn't quite consolidated, that's subsequently been mineralized. And then as you go away from the copper system, you end up getting more into the sphalerite zones, and you can see the sphalerite much prefers this layer of rock than these layers of rock. These are more silicious, a bit harder, a bit brittle, whereas these were carbonate rocks. So these sort of dissolved and allowed the fluids carrying the sphalerite to go through. So what's all the controversy about? Well, the main controversy has always been, did the lead zinc form first in the rock as the rock was forming on the seafloor and the copper overprinted? Or did it all form at once? That's fundamentally what it is. One we would call syngenetic, so formed during the lead zinc formed at the same time as the rock was forming and then has been deformed subsequently. Or is it epigenetic? Has it entered the rock later? The very first paper on geology of Mount Isa in 1937 concluded that it's a replacement system formed after the rocks had been deformed and broken. So essentially the rocks were all squidged up, and then the ores come in many millions of years later. But then, of course, when we discovered these things, you'll all be familiar with black smokers on the sea floor in the sort of 50s and 60s. When these were discovered, suddenly everyone thought, it must have all formed on the sea floor. So that's really when the debate started kicking off. So that great geological debate is over whether it was a seafloor lead zinc system with a copper overprint later, or whether it's a single system that came in. All of the research that I've done over the many years shows that it's actually a single system that came into the rocks much later, but not everyone agrees on that. And many people have many different views on how Mount Isa formed. But I'm not going to go too much into the geology right now. We can probably take a little bit of a look at the history of the town, in the sense that it was discovered, as we know, 100 years ago by this chap, John Campbell Miles, in 1923. Interesting guy. He'd worked previously around Broken Hill, so he actually knew what weathering of lead and zinc minerals look like, and he actually recognized the what we call the gossan, the weathered rocks on the top, the rusty rocks, and he actually picked them up and noticed how heavy they were because they're full of lead oxide, and he sent them away. And that's the very first some of the first workings, literally, and that's the first load of silver lead ore crossing the Leichhardt River. Back in the day, that's the first board of directors for Mount Isa Mines. And that's what the accommodation was. So whenever people used to moan about being in Mount Isa when I lived there, I'd always say, well, you've got it pretty good. You know, it's a lot better than it used to be. But it didn't really kick off until 1929 when the first train, they linked up the train from Dejara up to Mount Isa, and then they could actually get the ore away in appropriate amounts. So the town really only kicked off in the 1920s. And of course, it was during the 20s and 30s, it was just a lead zinc mine. They weren't, and well, silver, they weren't really mining the copper. The copper only became a thing from the Second World War onwards, when of course we needed to have a good supply of copper for munitions and things. And then of course, the copper price has been, generally the copper price is better than the lead zinc price, so copper's always been the sort of more flashy kind of, it makes more money than the lead zinc. So lead zinc's comparatively sort of boring, I suppose you could say, in some respects, doesn't make as much money. But yeah, as I say, the copper came in really from the 1940s onwards. The discovery outcrop, I don't know if any of you like minerals, but you can still pick some of these up in certain areas on the mine site. That's called cerusite, which is a lead mineral, pyromorphite, another lead one, anglicite, and there's various other copper and minerals as well. I'll put it just very briefly in the sense that this is a map I found in an old schoolhouse in South Australia from 1905, and of course it predates the discovery of Mount Isa. So Cloncurry was a very well-established town in 1905. They'd been mining there since the 1880s, even and the road even went very close to the future site of where George Fisher and Mount Isa were, and they were even mining copper about 20k south of Mount Isa at a place called Native B, where this photo's from. So there were people in the area, so no one had noticed it. And I think it is relevant to say that the average life expectancy back then was around 50 years, and they'd been mining for 56 years in Cloncurry. So a whole generation had passed with people going past these hills before anyone noticed. And again, this is kind of what those discovery outcrops look like. You see this kind of rusty material, and that's evidence of different types of mineralization. One thing I will draw your eye to, I mean, there's spinifex growing here, but this is a kind of grass which actually grows abundantly on mineralized outcrops. We call it copper grass, and it's actually very common all around Cloncurry and Mount Isa, and even in parts of South Australia where there's mineralization. It can tolerate soils with high copper contents. Copper is a natural fungicide, so fungus that can't live where there's copper in the soil, whereas this plant can, so it actually grows all over the place. And when I was working as an exploration geologist, I found it really useful to identify this plant. This is the Dugald River deposit. This is just up the road in Cloncurry, another lead zinc deposit, and there's the grass growing in monoculture across the ore. In fact, that's how they discovered that deposit. It actually has this classic vegetation anomaly. It was spotted by the first aeroplane to fly over it, so they say. And it's just very useful when you're prospecting. My friend Gavin and I came across this area. We were just walking through the bush on our way somewhere else, and we came across this, almost looked like a drill pad, or someone's taken a grader in there, but that was all natural. The ground hadn't been disturbed. That's just copper grass growing where the spinifex can't. So just a useful little thing I find to keep your eyes open with. The first geological descriptions in 1924 came out, and they nailed it pretty well. One of the first mines was called the Black Star Pit, and it was called the Black Star Pit because they would take the old fuel cans and cut the star out and then dab the black star on the bags of ore. So that's where that name came from, which I always thought was pretty neat. Obviously, during the 50s and 60s, it became one of the single largest creator of export income for the whole of Australia. This is a very rich mine. After 20 or 30 years of mining, they thought maybe we should look along strike, see if there's any more. And they actually found George Fisher and Hilton deposits about 20k north, just from prospecting and again finding those minerals at surface. And then, of course, from the 70s, that's when that giant 1100 ore body, the giant copper ore body, was found. And that's really when the sort of cash started really rolling in. But of course, as with most sorry, I just got something pop up on my screen. As with many companies, by around, wealth might breed a little bit of complacency, and the company became a bit top heavy and maybe not so efficient. So by the early 2000s, Mount Isa Mines was bought out by a company called Xstrata Copper, and that was for 5 billion Aussie dollars. And I worked for Xstrata when I was there. They were a very effective mining company, and production increased year on year, both copper and lead zinc during the Xstrata years. Let me just do that. So that was Xstrata Copper, who had the mine for about 10 years. Then in about 2013, there was a merger between Xstrata and Glencore. It was briefly called Glencore Xstrata, and then we had an email saying, can you stop using the Xstrata name? And it's become Glencore. Glencore allow Mount Isa mines to sort of operate quite there's not so much oversight. As long as Mount Isa mine provides its profits, then they sort of get left alone, and they just sort of run as an individual operation. Obviously, there's the copper system and the lead zinc that's all being mined. And, you know, there's enough lead zinc around Mount Isa to go for hundreds more, I'd say at least another 100 years on the lead zinc side. And they've been talking about doing a large multi-commodity open pit for many years. And I just put these in because every few years, Glencore or Xstrata threaten to close the smelter or pull out of mining. And of course, then everyone gets upset and says, what's going to happen to our town? And then the government gets involved briefly. So it's rare for a year to go by without Mount Isa making the news in some way. And recently it was that there was a housing crisis because there were so many people working there because the money was so good, there was nowhere to live. So anyway, just my last slide. Sorry if I've overrun a little bit. In terms of the outlook for the future, what do the next 100 years have in store? Well, as I mentioned, the elephant in the room back there is this giant cobalt deposit, and this chart here shows global refined cobalt supply, and we're already in deficit for cobalt. We don't have enough cobalt at the moment, even today. So at some point, someone's going to, you know, start looking at that. And of course, there's other metals as well: gallium, germanium. There's a whole host of metals and trace metals and critical metals that we haven't really considered before we go mainly for the lead and zinc and copper, but there's definitely potential there. And if everyone wants a Tesla, then we're going to still need to mine. You know, Mount Isa and George Fisher are still among the world's largest zinc, lead and silver deposits. There's huge potential for cobalt and other trace battery metals from tailings. And of course, if you take the cutoff grade a bit lower, there's still a huge amount of copper there, and there's still copper in the mine. They're mining very effectively at the moment. So the method of mining may change somewhat. The abundance or the mining rates may change in the future, but there's such a large amount of metal in the ground, and Australia's a safe jurisdiction to mine in. So I personally think that Mount Isa is going to be a great mine for another 100 years. And on that, I'll say thank you very much and invite Damian to ask me some questions.
Thank you very much, Richard, for giving us that excellent overview, both geologically and from the social dimensions. Just to start with, I'd like to draw your attention just to that plan view that you showed us, a geological question before I move off that. In terms of the ore body, if you don't mind showing that slide of the plan view showing the nature of the relationship of the copper bodies with the zinc ore bodies, the lead zinc.
Something like this.
Yeah,
one.
something like that. Because as a geoscientist myself, of course, straight lines in geology always draw attention, as do contacts. And one thing the first question, of course, is what's so special about the Urquhart Shale in terms of the prospectivity directly at Mount Isa, and then, of course, looking more regionally for upside. Specifically at Mount Isa there, it seems to me that, you know, you're talking about what probably is a calcareous dolomitic shale, and one has to wonder from a geological standpoint, has metamorphosis come into play with the emplacement? You're adjacent to an igneous body, and as dolomitization occurred where you get fracturing and emplacement for the copper, because you've definitely got a proximal distal relationship from the contact out to, there's a demarcation, a differentiation between the ore bodies. Can you address that?
Yes, I think we might need my entire one day, my one day, but no. Look, no, you're quite right. The Urquhart Shale is pretty special, but I guess the point being that there is actually the shale. It's very small. I think on this map, I think it's this green unit. You can see, and it doesn't poke. No, it's not the green one. It might be that pale red one. It's very thin. And people have obviously looked north and south. The Urquhart Shale hosts the mineralization at George Fisher, and also south at a place called Mount Novitt. And of course, there are other units that are the same age as the Urquhart Shale, so people have looked for that a lot. Personally, I think the Urquhart Shale is important because of, yes, the chemistry of it is the right kind of chemistry to drop out the metal into it. But as we can see, I think in this map here, you can see there's actually this yellow material is actually the silica dolomite, so that white mineral that I showed you, the dolomite calcite. And as you can see, that transgresses into the next unit, which is a siltstone. And you actually find all the way around Mount Isa, if you pull up the old maps of prospecting pits and things, there's actually an awful lot of shows in a whole bunch of other rock units as well. So while the Urquhart Shale is very important, it is the main host, it's not the only contributing factor to where that ore went. In terms of causative intrusion, we'll just go back one. You can see here there's something called the Sibella granite, and that is people talk about having to have a granite nearby, so there's actually a big granite here. It's the wrong age for the mineralization, but you see this red material here. These are actually pegmatites. These are very coarse grained granite rocks, and actually there's you can find beryl there. You can actually go and fossick for nice minerals in this area here. Now the age of that material is about the same as the predicted age of the ore, the copper and the lead zinc system in Mount Isa. So what we think it might be is that might actually be another intrusion even lower down underneath this one, and it leaked up around the edges of it. But yes, you do, to drive these systems, you do tend to need a heat source, and a big blob of molten granite is a pretty good heat source. And it's the same in Cloncurry as well. There's normally a causative intrusion, or an intrusion that's provided the energy or the heat to actually get all of this happening, and probably provide some of the metal as well.
And distance from that heat source can impact what metals you're going to get where, basically.
Yeah, so as I think I demonstrated in the image here, if you have metals in fluids, if you think of seawater, everyone knows there's various metals and salts in seawater. If you have a hot salty fluid like sort of super salty seawater and have that at about 350 degrees, that can hold a whole bunch of different metals. Now as that cools down, and cooling down either by traveling a distance or pumping into a cold rock, as that cools down, metal will tend to drop out in quite a predictable order. Chalcopyrite or copper can't really stay in that fluid once it gets under about 300 degrees, whereas sphalerite can stay in the fluid down to 150. It's much more sort of soluble in that sense. So the gradation we have in the metals, so that zonation of copper nearer the footwall or nearer maybe the hottest part where the fluid came in, and the zinc furthest away, is actually fits very well the ability of hydrothermal fluids to carry metal. So the zonation pattern that we see there is actually typical across many mines all around the world. You see copper in the hot bits and then zinc as you go further away, and different metals behave differently in those systems, but generally speaking.
No worries, thank you. Now, with regard to the demarcation and how it's delineated there in terms of the size of them, we all know that you talk about economic resources and then reserves. And of course, at the moment, it's delineated to a certain reserve size at Mount Isa. And that, of course, it depends on the grade of the ore, the given ores, and also the price. Now, given the fact that presumably there'd be emerging technologies, or I'm asking you, are there emerging technologies in both in terms of mining and processing to address lower grade ores, but also taking into account in conjunction with that all these rising and projected rising metal prices? Is it likely that the existing size of the reserves at Mount Isa will expand? I mean, you've alluded that the mines are seen to go on for another 100 years. Is that driven both by developments in both technology plus the demand and the resultant price rising?
Yes, absolutely.
And then a halo around those existing ore bodies.
Yes, absolutely. So on this cartoon here, you can see the darker yellow is 2% and the lighter yellow is 0.3% copper. So currently they don't mine anything under about 1% underground. Obviously you'd have to then transport it, get it to surface. It's more expensive. And the style of mining they've used in Mount Isa for many years is oh crikey, it's stoping. So what they do is they blast an area, a predefined area, remove that rock, and then fill that space back up with waste rock and cement. And then they next one and next one and next one. Now that's relatively efficient, but of course you can only mine small areas. So there are some other methods now, so called stoping, where what you can actually do is maybe, and this is just hypothetical, but you could make a development level under here and then actually fracture the rock and take it all out, and that would give some subsidence on the surface of the mine lease. But there's many mines here in South Australia that are going for what they're calling open stoping, sorry, not stoping, sub-level caving is what I meant to say, sorry. So I believe they've actually tried a bit of sublevel caving over underneath the Black Star area. So yeah, look, improvements, and again, we haven't really mentioned automation, but I suspect over the next 10 years or so, and it's happening in some mines all around the world, you're having automation, so humans don't even need to go underground very much, and potentially in the future, you know, you can fly a drone down and inspect and have remote controlled vehicles doing the drilling and remote control loaders doing the withdrawing the ore. So certainly as we go forwards, technology is going to have a huge impact on how we mine, probably increasing cost in the short term, but then lowering in the long term. Yeah, and again, if we were to take an even lower cutoff, say 0.1 copper, then the potential ore reserve gets bigger at that lower grade. But as you say, it's that fine balance between cost of mining and the metal price. But if the metal prices go where we're suspecting, which is generally up, I suspect it won't be a problem.
Just to ask you a little bit further about that, we're talking, you know, we've talked specifically about the Mount Isa mine there and the ore bodies there. Of course, there's potential upside with analogues and along trends, both in terms of contact and within particular, you know, formations like the Urquhart Shale within the Northwest Minerals Province. Can you give us an idea? One of the challenges that I believe anyway your NExUS program addresses also is the fact that a lot of these ore bodies are in substrate below overburden rock. And they've got to be basically explored for and then produced from below this overburden. Can you outline some of the challenges and some of the technologies, including especially from this geographical standpoint, any geospatial technologies as well as geophysical, geochemical? You've already spoken about the plants, copper tolerant plants, etc. But can you give us an idea of the technologies that are used for exploration, dealing with the overburden, and also the synergies that can be extracted?
Yeah, sure. So Mount Isa was outcropping at surface. So the rocks sort of along here, just behind the smelter, you can see they've got that kind of rusty color that I alluded to. So those are the Urquhart shales, and that was how the deposit was discovered. Obviously, the depth extent was learnt about through drilling, diamond drilling, where you drill down and bring back a section of the rock. In many, well, depending on what you're looking for, there are many different exploration techniques. Geophysics is one, and geophysics is going to measure the properties of the rocks. So there's some rocks are magnetic, some rocks are denser than others, some rocks conduct electricity better than others. For example, the Urquhart Shale is full of pyrite and graphite, so it's a very conductive rock unit. So electrical geophysics would work quite well to find that style of rock. Generally, exploration geophysics doesn't find. It's not telling you there's an ore deposit there, but it's telling you the properties of the rock match, you know, what we would hope that an ore deposit would match. Ways of seeing through the overburden, obviously geophysics, you tend to fly that in helicopters or low flying aircraft, or on the ground, you do ground geophysics. You can also do soil sampling, rock chip sampling, and analyze those for their geochemistry. And often you find, obviously, the rocks around in Mount Isa, where they're mining, would have more copper in than the rocks elsewhere. So that's how you can sort of monitor that. And obviously, as I mentioned, you can find different minerals and things like that. So there's lots of different ways. And again, exploration, you tend to use specific, depending on what you're looking for, you will use different techniques. So over in Cloncurry, a lot of the rocks have got magnetite in. Magnetite is a naturally occurring iron oxide, and it's magnetic. So if you want to find an ore deposit with magnetite in, you just have to fly an aircraft around with a big magnet on the back, and it will, well, obviously it's a magnetometer, so it's a bit technical, but it's essentially a magnet on the back of the plane. It tells you how magnetic the ground is, and if you've, you know, and that will work through many meters, hundreds of meters of overburden as well.
Yep. So basically the exploration side of things is fairly, you're saying, is very relatively low environmental impact, not intrusive at all. Obviously in the photo you've got on the screen, of course, and you have alluded to the fact that that may well be revisited in terms of cobalt to be extracted there. But what's the general performance in remediation after the mining operations have done, and the general track record going to the present day with operators like Glencore? What's their perception by the public and other stakeholders, and what is the reality, do you believe?
Yeah, look, historically, obviously, there've been less regulations, and it's improving all the time. Mount Isa Mines, for example, has a very dedicated environmental management team, Enviros we call them. They always monitoring water, wastewater, whatever's coming out the stack, all of those things. So there are plenty of regulations that people have to stick to, and in Australia we're very good at doing that, I think. I can't comment on, other places, but obviously Queensland's mining heritage all across the state. There's quite a lot of old mine sites that have been sort of abandoned, so to speak. Some of the old prospecting mines, obviously remediation needs to happen. These days, before you're given a mining lease or permission to mine, you have to have a remediation plan, and you have to put aside a certain value of money to actually pay for the remediation at the end of the mine life. That's fairly modern. That's only been in, for the last 20 or 30 years. In the past, that wasn't the case. So obviously there are case studies all around the world in every country where there's a legacy of that mining. We're getting a lot better at this remediation. Obviously, there's no need to remediate Mount Isa at the moment because it's probably going to be mining for quite a long time. But everything that people do on a mine site comes under a whole bunch of regulations. So certainly from my personal experience, I've always been very impressed with how people handle these things. There is an impact in mining. You're digging a hole or you're removing material. That's part of mining. So, I mean, I've been to mines in Cyprus that were mined by the Romans, and you can still see their slag heaps, and you can still see their shovel marks on the sides of the tunnels. So, it's been, as long as there have been humans, we mine, and that does have an impact, undoubtedly.
Before we go to questions from the floor, Rich, I think it's appropriate because you had the accolade of being a STEM Lecturer of the Year for your work with your NExUS project from the University of Adelaide. Would you like to give us a quick outline of the themes that they address, which are from a technical standpoint initially, at least there?
Yeah, look, I did put one little slide just at the end here. So the NExUS program started in 2016, and it's really, the aim of it is to try and give people graduating from uni an introduction to what they might be doing in the industry. I guess it was partly driven by, when I came to Australia in 2007, I just finished a 3-year undergraduate degree in exploration geology, did a PhD, another 3 years. And I got out to Mount Isa, and of course I hadn't learned any of what you actually do as an exploration geologist. And university is very good at teaching you a discipline, but they might not necessarily have much industry links. And in fact, a lot of the day-to-day tasks of a mine geologist are never covered at university. So, there was clearly a need. And obviously we can't cover everything during the 2 or 3 weeks of the NExUS program, but at least we try and just soften the landing a bit, introduce them to drill core, let them know what the daily duties are, introduce them to modern techniques to make them more effective explorers. And it's a lot of fun as well. It's all based in South Australia. We bring a cohort, that's the 2019 cohort. We have about 35 people. Any student in the country, any geoscience student in the country can apply. We also open up the applications to early career industry. Maybe people have been working for a small company for a couple of years and they would appreciate a bit of extra training. So I end up, and it's a great diverse group of people. We just simply ask them to write. We pull together 35 really keen geoscientists, and we bring them to South Australia. They're from all over the country, and we spend 3 weeks doing lots of cool stuff to do with rocks, and we take them to the cricket in Adelaide Oval and all sorts of fun things like that as well. So it's a bit of a team building experience. And when they finish, they go off to all corners of the country, into all different kinds of careers, and we've run it every year. Even managed to run it during COVID. We've had 267 graduates from the NExUS program now, and I'm literally, tomorrow morning, my job is to pick this year's cohort. So hopefully that'll take us over 300. And again, lots of people keep in touch, lots of friendships are made. People end up sort of living in shared houses together over in Perth if they have to move interstate. We've even had one marriage, so that they met and married a few years later. So no, it's a lot of fun, and I'm very proud of what we do. Obviously it's funded by the Minerals Council of Australia and BHP at the moment, but I'm still need to bring in funding to actually run it, because it's a not-for-profit sort of gig.
No worries. Thank you very much for that, Richard. I think it's appropriate at this juncture. Time's probably starting to run short, so we'll take a look at the chat line, and I believe there's some questions come in. See if I can address them, but we can.
I'll just, if you're okay with me keeping my, where are we? I'll keep my screen shared like that, and I can actually see there's one question from Henk.
There is one there that Henk's asked there, which you can read and address.
I can read that. Yeah, it says
I've got some other questions if the floor is short, but let's go with that.
Sure. What ratios of FIFO workers and living there workers, and how has that changed? Yeah, look, that's a really good question actually. FIFO, so fly in, fly out workers. Mount Isa, when I was living there, had a population between about somewhere, and again it depends on the metal price. If metal prices are high and there's lots of jobs that are well paid, more people move, and if it's not so good, people move away, and so the town fluctuates. I think maximum somewhere between 20 and 25,000, at the low point somewhere between probably something like 15 and 18,000, and I'd say it was probably around 18,000 when I worked there. In Mount Isa, if you work at the mine in Mount Isa, then you have to be residential, so you get a lot of young people coming and living there, but there are of course a lot of FIFO workers, and it's a bit hard to say a percentage wise, but I guess from the team that I worked in exploration, I was residential, and we probably had about a third of the people that would fly in and fly out. So if you scale that up across somewhere between 2,000 and 5,000 people who work at the mine, and then of course you've got all the people working for other companies exploring in the area. FIFO does make up a fair amount of the percentage, and look, it's fair to say that sometimes you hear some fairly negative things said by locals about FIFO workers. You know, they fly in, don't spend any money in the town, take it back to Brisbane or the Gold Coast, wherever they live, and I guess it's more about, I have heard people who've worked FIFO in Mount Isa be quite disparaging about the town, and that's disappointing because my family and I really enjoyed living in Mount Isa. There's a great community there. I really miss that actually, and you know, there's every sporting society and hobby that you could do there, so it's really what you make it, and if you're sort of one of the people who just wants to stay indoors in the aircon and watch telly, then you're probably not going to make the most of Mount Isa. So it's a great spot. We really enjoyed it, and I think FIFO seems to be, among the students that I teach, they prefer that. They'd much rather stay in big cities and then just fly out to the more remote working areas, which it's a bit of a shame, but it does mean that the people that do make the jump and live there, they're the people that I always, you know, they're the people that are clearly showing they've got a bit more drive and you know, willingness to put up with the rough, putting up with the rough and the smooth, I should say. I hope that answered the question.
To see if there's any other questions. Everyone's welcome to contribute questions at this time. I have another one in the meantime, Richard, is the with the NExUS program, you've spoken about getting those together over 2 or 3 week programs of students, graduates, and very much technical focus in terms of understanding ore bodies, architectural structure, all that sort of stuff, exploring beneath the overburden. What about closing the gap in terms of, you mentioned about making them well equipped to be a practical person in the field, but that does include, do you address dimensions beyond the technical to close that gap?
Absolutely. Look, you know, and you know, we don't sugarcoat anything. You know, there are issues in every industry. We talk about how people can best deal with maybe not so great things that happen in the workplace. We really emphasize being a good human, being a good person to work with, and you know, I guess the social aspects of working in teams and potentially working in remote areas. No, we try and cover as much as possible in a sort of holistic way, and yeah, we don't sugarcoat it. We have discussions about some of the issues that crop up, including
multiple stakeholders and those broader issues, those, you know, key stakeholder issues.
Probably, well, but stakeholders, that's something that's a positive. You know, it's great to build relationships. I mean, when you're exploring, you're generally the person that is out and about and bumping into the people who live and work on the land. So, you know, simply telling people to remember to shut the gate, you know, things like that. You know, use local businesses, all those things. Engagement with Aboriginal parties and native title is something I spent a lot of time doing. I really enjoyed it. I learned a huge amount from it, and it's something that is part of our obligations and legal rights. If we want to explore, we need to do the right thing on people's land. So it's all part of the process, and yeah, we certainly talk about that. We have cultural heritage training as part of NExUS, and you know, just like I say, encourage people to be kind and nice humans. That's one of the main things, really.
Thanks, Richard. There's another question in there from John, you may notice there.
Let me just pull that up.
Yeah.
Are there similar opportunities? Yeah, look, one of the things I really enjoyed about working in Mount Isa and Cloncurry was every year somebody discovered something different. While I was there, someone discovered a deposit called Merlin. It's the world's highest grade molybdenum rhenium deposit. We didn't even know you could do that in geoscience, and the rocks there are particularly fascinating. So yeah, look, I've been up to Mount Isa a number of times over the years and to look at the rocks, obviously, and since I've been here in Adelaide, and every year people are finding new things, and we're getting understanding improving all the time, and I'm always very optimistic that people will find more discoveries out there. And there's a whole, particularly now that the metal prices are creeping up, going up, there are plenty of deposits that haven't been economic that will become economic. So there's probably going to be a whole piggyback effect of these existing known deposits that haven't necessarily been economic will become mines in their own right in the future. So the whole district there's a lot of metal in the ground, and I think it's going to be an important generator of income for Queensland for many years to come.
Just building on John's question there, talking more broadly about the Northwest Minerals province, and you identified a number of mines and what's going on through there in one of your early slides. Is that under NExUS auspices within or without? Is there now a more integrated understanding of the emplacement, the architecture of these ore bodies? I know that's part of your themes.
Look,
in terms of then informing ongoing exploration and development.
Oh yeah, absolutely. That was one of the things that really got me. I originally did my PhD in the UK on geochemistry of particular rock units. I came to Mount Isa and had to learn from scratch really about ore deposits and particularly the deposits that we deal with. And after a couple of years, I realized that really we can always improve our understanding of these systems, and that's what actually got me back into doing research while I was working in Mount Isa and having honours students and PhDs come and learn about what we were exploring for and mining, so we could best inform our future decisions about exploration. And I guess that got to the point where I was probably spending about 10% of my time doing research on the job at Mount Isa, but it was probably providing about 90% of my motivation. So that's when I decided to make the switch and come back to uni in Adelaide and really try and ramp that up. And I'm very proud of what we achieved for Mount Isa. So I was working for Mount Isa Mines while at the University of Adelaide between 2015 and 2020. And we did a whole range of projects on Mount Isa, Cloncurry deposits, and a whole bunch of stuff in between, and coppergrass and all of that sort of thing. So it was certainly a lot of fun, and I think we've really we've answered a lot of the questions that we set out to do. So yes, certainly I'd say good explorers, good companies will always be continuing to learn more about what they're trying to find.
And that being the case, that has sharpened the ongoing exploration focus, and both in terms of, when you're saying there's a lot of metal in the ground, it connotes both high-grade ore, but also possibly low-grade ore resources now that could become reserves. Is that fair? That's fair to say,
yeah,
isn't it?
Absolutely. Yeah. All of these things, converting a reserve to a resource, or a reserve to a reserve, I always get those mixed up.
Resource to reserves, yeah.
Yeah, that always, that's all, function of costs and metal prices and things. But no, certainly, yeah. These days are probably a generalisation, but for the deposits around Mount Isa and Cloncurry, generally about 1% copper or a little bit more, with sometimes a little bit of gold involved in the Cloncurry ones. Whereas big deposits over in South America, these big porphyry deposits, they mine those down to sort of 0.3, even 0.2% copper. But it's the mining style that, big open pits that make it cheaper. So, I mean, they've been talking about doing an open pit for the Mount Isa system since the 1970s. Whether that happens, I don't know. There's obviously lots of considerations to do before you do that, but a lower grade open pit type mining system is always going to be cheaper to operate. So yeah, lower grades will become more attractive, I think, depending on the metal market.
As they contemplate a big open cut mine at Mount Isa, what's the feeling in the community, and is there opposition to it? I mean, it's obviously going to leave a giant scar in the ground like we see at Kalgoorlie. Well, and obviously remediation comes into that.
Yeah, look, I think, like I say, it's been talked about for a long time, and people who live and work in Mount Isa want to see Mount Isa thrive. They want to see the town continue to thrive. Now, the town is just here on the left, and I think that's the railway line, essentially. Now, the Urquhart Shale that hosts the ore, everything's to the this side of the line, so to the west of that line. So if there was to be an open pit, it wouldn't affect
that being the strike direction, Richard, is it? That's the strike
yeah,
direction of the
bank, sort of north to south, parallel to this line. And if there was to be an open cut, then it would be these areas here. And I don't believe it would affect. Obviously, they'd have to take into account the blasting and those things, but if you live in Mount Isa, you hear the blast twice a day anyway, so it's not particularly new news to you. But yeah, the one of the problems with a multi-commodity pit would be that it's actually underneath all of this infrastructure, so you'd have to move all of that, which is a great big job in itself. And there's a lot of value, obviously a lot of wealth there, investment that probably people don't want to do. So yeah, if it was to ever go to a lower grade, large multi-commodity mine, there'd be quite a lot of changes in the town. But again, the ores, there's a lot of ore there at lower grades. So and I think that I'd expect the community to support it, because you know, a thriving community with the mines, obviously the sort of the heart of that.
Yeah. Is there a role for NExUS in conjunction with peak bodies like the Institute of Metals and Metallurgy in terms of educating the broader community? You showed your cartoon there of you know, people protesting and whatnot, of course, but still wanting their consumables, or not even consumables, but new items, as you mentioned. What do you see? Do you see much of a gap there between, you know, perceptions in the community and as you pointed out, as we're in this transition phase, there is that, you know, inevitable rise in demand for these key trace elements, these energy elements.
Look, as I mentioned in the talk briefly, it's very rare to hear a good news story about mining. The media's you know, always sort of paints mining as being, you know, the destroyer or something that's bad. Yet it forgets that we need this stuff. We wouldn't be watching it on the TV because the TV wouldn't have been made. You know, so it's a circular argument, and unfortunately, just across the board, across you know, just in our society, mining is generally not very well known about. People just don't know about geology, and of course we're seeing that in enrollments at university. People just don't know about geology. The enrollment numbers in geoscience are going down every year, and that's causing university departments to actually close. 2 or 3 geology departments have closed in the last few years, just at the point where we need more informed geoscientists to do it properly and to find all this ore for the metal that we need. Just at that point, enrollments are going down. So there's been a real sort of growing sense of trepidation in the geoscience world, that, you know, where are the next generation going to come from? And of course, you know, if the general perception of mining is negative, if kids are being taught at school that mining's bad, then they're not going to want to go into that as a career. So I have spent a lot of time. We actually have NExUS has a small YouTube channel. We're trying to make some sort of geoscience education videos about, you know, rocks being cool and stuff like that. But mining's always had an image problem. You may have noticed on the TV in the last few years, BHP have started advertising a bit more proactively. But we've got a long way to go, just to sort of actually let people know why we need mining and why we need these metals. As I've said, I think it would be great if we used less materials and didn't need to mine so much. But you know, in developed countries in the West, or the developed nations, we have that sort of luxury of deciding what we use. Whereas, you know, there's a lot of people in India and Africa who want a new phone. So we've got, you know, what are we going to do? So it's you know, it's a challenging position to be in, but I think we do need to be a bit more realistic about where our materials come from. But I've been racking my brain for years as to how to best get the message across, but it's challenging. It's really challenging.
Yeah, no, it truly is, in both the mining and the petroleum. Well, of course, the petroleum also, to that matter as well. Thank you very much. I don't believe there's any more questions. We're coming to the end of the hour. It's been tremendous. Thank you, Richard, for your expansive answers, both in your strong presentation, very elucidating, and then your very expansive answers to the questions from myself and from the floor. So much appreciated. And with no further ado, I think we'll hand back to John there.
Oh, I'll stop my share. Thanks very much for having me. It's been a pleasure.
All right. Thank you again, Damian. Thank you, Richard. A fascinating and really insightful session. I know I've learned a hell of a lot more about the ore body out there at Mount Isa and many of the both future and past challenges that the area's faced. So thank you again. As we mentioned a bit earlier, we've got plenty more events coming up in the next month. Check out the website and our socials for that. And without further ado, we'll call it there for the evening. Thank you again, everyone. A recording of tonight's session will be available on YouTube very soon.
Cool. Thank you very much.
A very good presentation.
Cool. Thank you.
Thanks, Richard.
Thanks.